Imagine waking up one day, and the sun just stops moving across the sky. No sunrise. No sunset. Just one side of Earth stuck in eternal daylight, and the other in endless night. Sounds impossible, right? But what would actually happen if Earth suddenly stopped rotating? The answer is far scarier than you think, and it starts in the first 10 seconds. Section 1. The immediate catastrophe. Earth doesn't just rotate, it spins at about 1,670 km per hour at the equator. Everything on the surface, including you, the oceans, and the atmosphere, is moving at that same speed. Now imagine that speed vanishing in an instant. Physics has a name for this: inertia. Objects in motion want to stay in motion. If the ground beneath us suddenly stopped, but the air, water, and even our own bodies kept moving at 1,670 km per hour, everything would be flung sideways. The oceans alone would trigger mega-tsunamis, wiping out entire coastlines. Hurricane-force winds stronger than anything in recorded history would tear across every continent. Buildings, forests, mountains, nothing built for this kind of force would survive. Section 2. The slow stop scenario. But let's say, hypothetically, Earth stopped rotating gradually, over months or years, not instantly. This removes the catastrophic wind and wave disaster. But it creates a new, slower nightmare. One side of the planet would face the sun permanently. The other would stay in darkness forever. The day side would become a scorched wasteland, temperatures soaring high enough to boil water and destroy farmland. The night side would freeze over completely, becoming a frozen wasteland colder than Antarctica. Section 3. What happens to the magnetic field? Here's the part most people don't know. Earth's rotation isn't just about day and night, it powers our planet's magnetic field. This field is generated by molten iron swirling in Earth's core, a process driven by rotation, called the geodynamo. If rotation stopped, this magnetic field would weaken and eventually collapse. That magnetic field is our invisible shield against solar radiation and cosmic rays. Without it, the sun's radiation would strip away our atmosphere over time, the same way scientists believe it happened to Mars billions of years ago. Section 4. Could anything survive? So could life survive at all? Possibly, but only in a narrow strip along the border between the burning day side and the frozen night side. Scientists call this the twilight zone, a thin ring around the planet where temperatures might stay survivable. This isn't just science fiction speculation, it's similar to conditions we study on tidally locked exoplanets, planets around other stars that always show one face to their sun. Section 5. How would this affect technology and satellites? Here's something most people never think about. Our entire modern world runs on satellites, GPS, weather forecasting, internet, communication. All of these satellites are placed in orbit based on Earth's rotation. If rotation stopped, satellite orbits wouldn't instantly fail, but the systems relying on precise timing, like GPS, would slowly drift into chaos. Every map, every flight system, every navigation tool would become unreliable. Section 6. What would ancient civilizations have thought? Throughout history, civilizations built their entire calendars, religions, and agriculture around the predictable cycle of day and night. The Egyptians tracked the sun's movement to build the pyramids with incredible precision. Ancient Mayans built entire temples aligned to solstices. Now imagine this cycle just stopping. No sunrise to mark a new day. No sunset to signal rest. For early humans, this wouldn't just be a scientific event, it would be seen as the end of the world. In fact, many ancient myths already describe a day the sun stood still, stories passed down for generations about a moment when time itself seemed to freeze. Whether myth or memory, it shows just how deeply human survival has always been tied to Earth's spin. Section 7. What would happen to the Moon? Here's an interesting twist. Even if Earth stopped rotating, the Moon would keep orbiting us, because the Moon's orbit isn't caused by Earth's spin, it's caused by gravity. But here's the catch: tides on Earth are created by a combination of the Moon's pull and Earth's rotation working together. Without rotation, tides would behave completely differently. Instead of rising and falling every few hours, ocean bulges would simply stay fixed, facing the Moon permanently. Coastal areas facing the Moon could remain flooded, while others could dry out completely. Section 9. Could we survive by moving underground? So if the surface becomes unlivable, could humanity survive by going underground? Actually, this idea isn't just science fiction. Scientists already study underground habitats as a backup plan for extreme climate events, even for future Mars colonies. Underground, temperatures stay far more stable, protected from the extreme heat of the day side and the freezing cold of the night side. It wouldn't be comfortable, but it could be one of the only realistic ways for life to continue. Section 09. How long would humanity actually have to prepare?
Now here's some good news. Even in the most extreme hypothetical version of this scenario, Earth's rotation wouldn't just stop instantly. Nothing in nature works that way. If such a slowdown were ever possible, it would happen over an extremely long timeline, giving humanity time to observe, adapt, and prepare. This is exactly why scientists study these what-if scenarios, not because they are likely, but because understanding worst-case physics helps us prepare for real, smaller-scale climate and space challenges we already face today. Section 10. What if this happened to another planet instead? Interestingly, there's a planet in our own solar system that already shows us what extreme rotation problems look like: Venus. Venus rotates so slowly that one single day on Venus is longer than its entire year. It takes about 243 Earth days just to complete one rotation. And the result? Venus has the hottest surface of any planet in our solar system, hot enough to melt lead, even hotter than Mercury, which is actually closer to the Sun. Mercury, on the other hand, is tidally locked in a strange 3-2 spin orbit resonance, meaning its rotation and orbit are directly tied together, creating extreme temperature differences between its day and night sides, similar to what we described for a non-rotating Earth. So when we ask what if Earth stopped rotating, we're not just imagining fiction, we're looking at real examples happening right now, just a few planets away. It's a reminder that Earth's rotation isn't just a background detail of our planet, it's one of the key reasons life exists here at all. Conclusion. So while Earth stopping its rotation is essentially impossible, exploring what if helps us understand just how fragile and finely tuned our planet's balance really is. If you found this fascinating, hit subscribe for more deep dives into the extreme physics of our universe. And let me know in the comments, which what if space scenario should we explore next?